Okay, so good afternoon.
Pila ka module ni sir?
Module 3 na ni karon, pero wala tayong module 2, ambak ta sa module 3. Okay? So quarter
sir.
2, module 3, wireless network configuration. Okay. So last meeting we discussed router, no? Router configuration. So sige daw kinsa maka recap about router. Sige, si Limco ba? Akong paborito si Limco ba? O Limco, unsa ba mo natun-an sa router?
Ako?
Hmm. So, nag-usa ta last meeting.
Ano, kung sa taman? Pila... kalimot ako.
Putang ina na ba?
So, last meeting we discussed about router configuration, no? So, we also differentiate router and modem. So, when we say router, so router siya tong nagahatag og signal, no, extends signal of your internet connection, no, while modem is siya lang ang kanang main server, di ba? So we also discuss hub, no, so in terms sa extension, si hub ang mas daghan ma-connect, di ba? Okay, so i-run through na to ang module. So, okay, after going through this module, you are expected to first identify the function of repeaters, wireless access point, then configure a wireless network, configure wireless access point, configure router as access point, and configure firewall. Okay, so what I know is pretest, no? So sige, answera na to ni. Si kisa mauna, si Limco, okay. Post na to ni uban ha. Limco, sige, go, basa.
Which network device is used to amplify or regenerate a signal over the same network to extend the range of coverage area of the network? Access point, wireless repeater, secondary router, all of the above.
So, sa answer.
B?
B?
Oh,
Boy?
B.
The answer is letter D, dog. No?
Ay,
So, si access point, wireless repeater, and router is they all amplify or regenerate signal. No? So, sila ang gina-extend ang signal, sila ang nagapa-enhance sa signal sa imong internet connection. Okay, kani. Number 2, relator, pakibasa. Oy, wala kay microphone. Paki-on imong microphone. Yan. Very good. Sige. Relator, basa. Number 2.
The optimum maximum length of the UTP cable is A. 25 meters, B. 50 meters, C. 100 meters, D. 150 meters. C.
Okay, the correct answer is letter C. Kuyawa. Uy, thank you sa answer sheet. Answer K.
Ito ang module.
Okay. Stock knowledge na ito. Okay, next, number 3. Si Big Boy, anak ni Big Boy.
Wait lang, sir.
Number 3. Anak ni Big Boy, basa.
What is a network of devices that is not connected by cables? A. Wireless network. B. Cableless network. C. Bluetooth network. D. Radio waves network. A. Wireless network.
Ngano man?
Not connected man siya by cable. So, ibig sabihin sa wireless, sir, hindi na siya, hindi na siya gagamit ng cable.
Okay, very good, no? So, sa name itself na wireless, meaning wala nagagamit ng cable, 'di ba?
Po.
So, very good, no? So, the answer is letter A. Yawa eh. Next, number 4. Aranton, basa.
Number 4. Which of the following is used to connect wireless networks? A. Bluetooth. B. Radio waves. C. Sound waves. D. Dedicated list line. A. Bluetooth. Tama, sir.
Connect wireless networks. Connect wireless. Which of the following is used to connect wireless network? Okay, tama. Pwede siya Bluetooth. Kaya wireless mo ng Bluetooth, di ba? So, the correct answer is letter A, Bluetooth. Mali si answer key. Next, number 5. Payot.
Can a router connect to wired local area network? A. Yes, by adding another router. B. No, it can only be done by switch. C. Yes, by connecting the two switch to one router. D. No, it is too heavy for the connection, thus making it slow.
What's man answer?
Letter
Can a router connect to a wired local area network? Okay, no? So the correct answer is letter C. Yes. No, by connecting the two switches to one router. No, so we can connect local area network, no, to local area network. Very good. Okay, last. Kisa basa si relator na pod be. Relator, basa.
Which which device uses a DHCP system that assign IP addresses to device connect to the network? A. Hub. B. Router. C. Switch. D. Repeater.
Saan, sir?
Wait lang, sir.
Kisa ba ang naghatag automatic og IP address sa ilaha?
D. Router.
Okay, babe. Kuyaway, very good, no? The answer is letter B. No? So, only router can give IP address, no? So, use DHCP system, no? So, siyang nagagamit kay si hub wala man. Si switch wala pod. No? So, the correct answer is letter B, router. Okay. Next, number 7. Relator, basa.
Nangalan naman ka, sir.
Oh, panagsalag mo ka rin. Pang one time eh. Antod 10 na imong basahon.
Lain naman.
Sige. Number 7. Number 7.
What does DHCP mean? A. Dual host control protocol. B. Dynamic host control protocol. D. Dynamic host calibration protocol. D. Dynamic host configuration protocol. Letter D.
Okay, the correct answer is letter D. Kuya, relator. Okay, so paki-answer na lang sa inyong module ha. So kani siya pre-test what I know. Paki-answer na lang po na. So we have 20 items. So lesson 3, wireless configuration. So kani no? How will you connect local area connection? Ito yung Eh. Okay, no? So, paki-answer na po ding what's in. So, we have 5 questions. So, ang ano is i-answer na lang sa yellow pad. No? Okay. Next, natay what's new. Scenario ni siya. Scenario hantod 7. Sige. Next. What is it? So, what is it is lesson proper sa inyong module. No? So, natay ano diri switch mao ni ang example of network, no? So, we have two switch. So, switch to switch, ang gamiton is crossover, no? Straight to siya pag switch to PC. So, as you can see sa illustration, sa drawing, so we have two route switch, then connected by crossover internet cable. Then, under the switch, we have 3 units, no? In room 1. So, gamitan siya ng straight through LAN cable. Then, in room 2, same gihapon, no? So, what is repeater? No? So, a repeater is a network device used to amplify or generate signal over the same network to extend network range of coverage area. So, ang repeater is kung nakaka-internet connection, then gusto nimo ipa-extend sa layo. So, mao na imong gamiton si repeater, no? So, ana. So, option 1, option 2. So, what is wireless network? So, a wireless network by its name alone is a network of devices that are not connected through cable. So, tama to si si Unggal, no? Na device in a network are connected wirelessly using radio wave. So, a wireless network is possible using wireless router. No, so a router connect to the wired LAN, but it is also a capacity for a wireless LAN. So, setting up wireless network. So, kabalo na ba mo tanan mag-set up of wireless network? So, as you can see, una-una, kailangan yun mo mabalaan unsay mo IP address. So, IP config. So, first, go to control panel. Then, pangitaon mo yung wireless Wi-Fi. No, muna. Then, click the details. So, makita ninyo kung asa mo connected na IP address. Okay. Next. So, in your router, di ba unsa ba ang default IP address sa router? Ay sa router ganini no, access point or router. Unsa ba ang default IP address? Kisa makainomdom last year. Relator.
Di ko na maalala, sir.
Di mo maalala. Si Limco. Si Limco kay paborito niya ni. Limco. Paano nimo mabalaan imong IP address sa imong router? Asa makit-an?
Sa ano? Sa tawag man ng basta ito man to siya.
Siyempre, dito rin mo makita sa likod sa router. Di ba? May nakabutang dito na IP address. Okay. Unsa ba ang default username and password ni
Admin?
Okay, very good, no? So, the default password and username is admin. So, in the wireless tab, input the name of your wireless network in a wireless network name, no? So mao ni. Okay? So pag na-input na nimo, so disable yun na to si ang security, no? Kana. Sige. So what is DHCP? So DHCP is Dynamic Host Configuration Protocol. So it is a system that assign dynamic IP address to device on a network. So kani ang DHCP. So ibig sabihin sa DHCP, siya ang automatic na mohatag og IP address sa imuhang PC, sa imuhang cellphone, no? So kung tahay kani sa picture, sa illustration is 192.168.1.100. The other is 192.168.1.199. So ibig sabihin ang unit na makasulod sa iyaha is only 100, no? Or 99. So ibig sabihin 99 lang ka units ang pwede makasulod. Pag napuno ang 99, ibig sabihin hindi na makasulod ang uban sa internet. So mao na siya pag-configure. Okay. So sundon lang ninyo ni, no? Tanawa lang ninyo sa assessment, magamit magud nato ni, no? Sige, maghatag lang ko niya video. So what is wireless access point? So wireless access point, no, is a same way of repeaters do. Only that they can give access to a wireless devices, no? So it relays data between a wired network and wireless data. So pinaka-example is ang internet connection nato sa school, no? Gikan sa admin office, no, labay-labay lang siya signal gamit ang wireless access point. So mao na ang power ni access point. Ginalabay niya palayo-palayo sa kuntahay kani, no? So natay setup router or imong internet connection. So sa second floor, butangan nimo siya og access point wireless, no? Pag abot sa third floor, wireless gihapon. So ibig sabihin dili na siya mag-connect pa imong wire. So mas limpyo ang pagbutang og access point. Okay. So how to set up access point? So mao ni. So na ako yung mga video na ipa ano lang ako sa inyo ha. So habang wala pa tay actual, so pwede pa mo magtanaw-tanaw na lang sa video. So what is firewall? So firewall is an application that keeps your system from network threat like unauthorized access to your system or application that may harm your computer, no? So pag naka-on ang imong firewall, no, so dili ka prone sa mga hacking or dili ka prone sa mga virus. Okay. So see, what's more, ansiran daw nato ni 5 lang ato ansiran ha. Sige, pakibasa. Kisa mo basa ni. Number 1. Si relator, basa. Number 1.
Hubs and switches can function as repeaters.
True or false?
True.
Nga naman. Nga naman. Nga naman. Pwede ba dahil ang habog ang switch may repeater? So, siyempre, the correct answer is false eh. Mali ang answer key. Answer key yun nagpasa. No?
Wala siya, uy.
Next, number 2. A wireless network is possible using a repeater. True or false?
Let's go.
Ha?
True.
Okay, true. Kuya, mali na po ang answer key. False 3. No, a wireless network is possible using a repeater. No? So, Wireless network is possible using a repeater.
Kim lang bata. True na, sir.
Oh, true. Next, number 3. Using ipconfig is the only way to check the router IP address. True or false?
True.
True.
Pakim.
Number 3,
True.
false. Dili naman.
Trolls.
Only way to check your router's IP address. Tama. True.
Oh, true.
Mm.
Trolls.
Next, number 4. Disable security if you want everybody to connect your wireless network. True or false?
Relax lang.
I-disable daw nimo security nimo para makakonect imong uban sa wireless network. True or false? Number 4.
False.
False.
Siyempre,
False.
siyempre true.
Ay, true.
True. Number 5. Each time a device connect to a network, an IP address must be assigned manually in the router. True or false?
True.
False.
Ay, false.
True.
Kim Wamos.
Okay. Sige. So next is part 2. Kanisa is ano niya siya if naanatay face to face, no? So wala pa man tayo face to face, so digya pa nato ni mabuhat. Okay. Next, what I have learned. So using the diagram below, write the similarities and difference of the following devices. You may add more properties of each if you need to, no? So based sa inyong module or sa inyong natun-an, unsa ang wired repeaters, wireless router, and wireless access point, no? So ibutang ninyo diha. What can I do? Mao lang gihapon answeran ninyo ni. Then natay ano diri? Next is assessment. Assessment is natay 3 parts, no? So answeran siya right R if referred to a function, or
Ang bata.
W repeater, a wired repeater, AP if wireless access point, and wrap for both, no? So
Kim lang bata. Uy, walang
mga
maingay.
answeran. Okay. So na ako'y mga video dre, no, i-present ako karon para makita ninyo. Okay, so this video is about wireless access point and wireless router. So sabay lang difference, no? So bira to lang.
Hello everyone. In this video, we're going to talk about the difference between a wireless access point and a Wi-Fi router. Now, a lot of people think that these two devices are the same thing, but even though they do look similar and they do similar things, they are in fact different. So let's first talk about a Wi-Fi router. Now, almost everyone who has an internet connection in their home would have a Wi-Fi router, whether that Wi-Fi router is a separate device or if it's built into their modem. A Wi-Fi router is what allows multiple wired and wireless devices to join together in a local area network. It'll broadcast a Wi-Fi signal so that wireless devices can connect to it, and it'll also have a built-in switch with several network ports so that wired devices can connect to it using Ethernet cables. And then that Wi-Fi router will directly connect to a modem to give those devices internet access. Wi-Fi routers are mainly used in homes and small offices. So here we have a typical home where a couple of desktops are connected to the Wi-Fi router's built-in switch using cables, and we also have laptops and tablets that are connected wirelessly to the router. So now let's talk about a wireless access point. A wireless AP relays data between a wired network and wireless devices. It's basically a wireless hub that's used by wireless devices to connect to an existing wired network. A wireless AP connects directly to an organization's router where the router is then connected directly to a modem, which gives the wireless devices access to the internet. Now, wireless access points are primarily used by medium to large organizations. And typically, an organization will have multiple access points to make sure it covers the entire building. So, for example, here we have a medium-sized office. And this office has desktop computers, laptops, and tablets. So the desktop computers will connect to the organization's router using Ethernet cables. But in order for the wireless laptops and tablets to connect to the network, this office is going to use wireless access points. So the access points are going to be placed in strategic places, and each of them will connect to the router using an Ethernet cable. Then once that is done, they will all broadcast a Wi-Fi signal so that the laptops and tablets can connect wirelessly and join this network. So now all the desktop computers and wireless devices are joined together in one network. And that one network is managed by one single router. And because wireless access points are managed by a single router, that is one of the main reasons why larger organizations use wireless access points instead of Wi-Fi routers. Now, in reality, this office here can use Wi-Fi routers instead of wireless APs, and it would work just fine. But the problem with using Wi-Fi routers instead of wireless APs is manageability. If the network administrator wanted to manage this network and make certain changes, he would have to log into each Wi-Fi router to make that change. And that could be a hassle and time-consuming, especially if there were a lot of Wi-Fi routers. But if this office was using wireless access points instead, then all the management and all the changes in the configuration would be done by this single router, which makes managing a network a lot easier. So all the wireless devices can be treated as a single subnet instead of being treated as multiple subnets if Wi-Fi routers were used. Another difference between these is how devices are able to connect to them. Wireless access points are strictly for wireless devices to connect to, whereas Wi-Fi routers are able to accept connections from both wireless devices and wired devices. Because in addition to having a Wi-Fi antenna, Wi-Fi routers will also have a built-in switch to accept Ethernet cable connections. Another difference is a firewall. Wireless access points don't have a firewall, while Wi-Fi routers will have a firewall. Wi-Fi routers will also have a built-in DHCP service. A DHCP service is what automatically assigns IP addresses to devices that are connected to it. So when devices connect to a Wi-Fi router, its built-in DHCP service will directly assign those devices an IP address. But since wireless APs don't have a DHCP service, the devices that are connected to it will get its IP address from the organization's router. So once a device connects to the wireless AP, the router will send the IP through the wireless access point and then to the device. And another difference is that Wi-Fi routers will have a WAN port or internet port. A WAN or internet port is where you would plug in a network cable coming in from your modem. And this is what gives your Wi-Fi router an internet connection so it can pass it on to other devices, whereas a wireless access point doesn't have a WAN or internet port. So it cannot directly connect to a modem. It has to connect directly to a router instead, and then the router is what connects to a modem. And on a final note, wireless access points are often used to further extend a network's existing wireless signal. So for example, if this home needed to extend its Wi-Fi signal further into this home, you can attach a wireless access point using a network cable to the Wi-Fi router so that distant devices can connect to the Wi-Fi signal.
So, ingon sa video, no? Ang router is siya gyud to ang main source of internet, di ba? Pag once na gusto nimo siya extend, so saka pa ka mo gamit og wireless access point. So ang difference pod nila is si wireless access point ay wireless router, pwede siya makahatag og IP address while the access point magdepende siya sa router. Oh, so inana. Okay. Next is nako video dre about modem and router. So what is the difference between the modem and the router? Okay. Sige.
Router. Because a lot of people actually think that a modem and a router are the same thing, but they are not. They are different with two separate roles on a network. So I'm going to explain the difference between the two. Now, if you want internet inside your home or business, you have to have a modem. A modem is what brings the internet into your home or business. A modem establishes and maintains a dedicated connection to your internet service provider to give you access to the internet. Now, the reason why you have to have a modem is because of the two different types of signals that are used on a computer and on the internet. A computer only reads digital signals, while signals out on the internet are analog. As analog data comes in from the internet, the modem demodulates the incoming analog signals into a digital signal so that a computer can understand it. And a modem also modulates outgoing digital signals from a computer into an analog signal as it goes out on the internet. And this is where we get the word modem. The word modem means modulator demodulator, which is exactly what a modem does. It modulates outgoing data from a computer and demodulates incoming data from the internet. Now, a router comes in after the modem. Now, there are different types of routers. There are routers that are used in businesses and larger organizations, and there are smaller routers that are used in homes and small businesses. But they basically do the same thing. But for this video, we're going to use the small office, home office router that most of us are familiar with. Now, a router is what routes or passes your internet connection to all of your devices in your home or business. It directs it to all of your computers, tablets, phones, and so on, so that those devices can access the internet. A typical small office, home office router like this one here will have a built-in switch with multiple ports so that you can connect multiple devices using an Ethernet cable connection. And it also functions as a wireless access point so that wireless devices such as tablets and laptops can have internet access. Now, technically, you really don't need a router if you only want one of your devices to access the internet. You can just plug that device's network cable directly into the modem, and then you'll be able to access the internet. However, like most homes and businesses, you're going to have multiple devices that need access to the internet, and that's where you would need a router. There are also different types of modems. Two of the most common types are cable and DSL modems. So depending upon what type of internet you're going to use, you need to use the correct type of modem. Cable modems are connected to your home using a coaxial cable. Cable is typically provided by the same company that provides you with cable television, such as Comcast, which is one of the largest providers in the United States. And DSL modems are connected using a typical phone line. DSL is provided by companies such as AT&T, which is the largest provider in the US. Now, a lot of times, your internet service provider, when they send you a modem, or if you were to buy one at the store, the modem might be a modem-router combination. So it will be a modem with a built-in wireless router in one physical device, such as this one here. So here is an example of several different networks on how they connect to the internet. For example, this network here on the left is using a cable modem, and it's using a small office, home office router so that its computers and the tablet can have internet access. On the bottom we have another network, and this network is using a DSL modem, and it's also using a small office home office router so that its computers, the laptop, and the tablet can access the internet. The network here on the right is an example of a business network, and it's using a cable modem and it's using a business router so it can connect its computers and its server. And finally, we have the network here on top, and this only has one device that needs internet access. So it doesn't need to use a router. It can just directly connect to the modem because only one device needs internet access. Now, if you're wondering how hubs and switches relate to routers and modems, especially if you saw my other video where I explained the differences between hubs, switches, and routers, well, keep in mind that most routers will have a built-in switch inside of them. So there's no need to have a switch if you already have a router that has a switch built into it. So for example, a router like this may have a 4-port integrated switch so that you can connect 4 Ethernet cables for your wired devices. So the only time that you may need to add a switch to this network is if you needed more wired connections for your devices. So you can just connect a switch to your router and then add more connections to the switch. So just to clear things up even more, over here we have the internet with all of its routers. Then as the internet is routed into this private network, it first reaches the
Okay, so ang difference ni modem and router, si modem is siya tong main source sa internet connection ninyo, no? So pag mo gamit na ta og daghan unit or gusto ninyo ay Wi-Fi, so mo gamit tag wireless router. Okay. So sa karon na mga models, no, na tayo ginatawag na 4-in-1, 3-in-1. So ibig sabihin na atay modem, same time wireless router na siya and access point na, no? So napod siya built-in na switch or hub. So mao na to example is the mga globe modems, no, or globe tattoo. O mao na sila ang murag hybrid na ana tanan. Okay. Next video, no. So na ko ipakita na pod is about switch, hub, switch, and router. So na siya brief explanation, no, kung sa ang tatlo. Kay panagsama ano na to. Taga na mamaliog sabot sa tatlo. Okay.
Hello everyone. In this video, we're going to talk about the difference between a hub, a switch, and a router. Now, all three of these devices are similar, but there is a difference in the way they handle data. So we'll first talk about a hub. Now, the purpose of a hub is to connect all of your network devices together on an internal network. It's a device that has multiple ports that accepts Ethernet connections from network devices. Now, a hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where the data is supposed to be sent. And that's because the only thing a hub knows is when a device is connected to one of its ports. So when a data packet arrives at one of the ports, it is copied to all of the other ports. So all the devices on that hub sees that data packet. So again, a data packet comes into one port, then the hub will just rebroadcast that data to every port that has a device connected to it. So even if this computer here only wanted to communicate with this computer over here, these other computers would still receive the data even though the data was not intended for them. So when this happens, it not only creates security concerns, but it also creates unnecessary traffic on the network, which wastes bandwidth. Now, a switch is very similar to a hub. It's also a device that has multiple ports that accepts Ethernet connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these physical addresses, called MAC addresses, in its table. So when a data packet is sent to a switch, it's only directed to the intended destination port, unlike a hub where a hub would just rebroadcast the data to every port. So as an example, if this computer here wanted to communicate with this computer over here, the data packet arrives at the switch, and then the switch will look at its table of MAC addresses and matching ports and deliver the data to the correct port. And then the data packet would only go to that computer. So that's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network. So as a review, a hub only detects that a device is physically connected to it, and a switch can detect specific devices that are connected to it because it keeps a record of the MAC addresses of those devices. Now, hubs and switches are used to exchange data within a local area network, for example, such as in your home network or in a business. They are not used to exchange data outside their own network, such as out on the internet, because to exchange or route data outside their own network to another network, such as out on the internet, a device needs to be able to read IP addresses. And hubs and switches do not read IP addresses. So that's where the router comes in. Now, a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another based on their IP address. When a data packet is received from the router inspects the data's IP address and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway of a network. So here we have a private network with its router, and we'll refer to this as the red network, indicated by the red colored screens on the computers. And over here you're going to have different data packets, indicated by their different colors, which represents different IP addresses, and they are going to be entering the red network's router from the internet. Now the router is only going to accept the red data packets, because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network because their IP addresses were not meant for this network. Now here is an expanded view of routers over the internet. There are 4 networks here, indicated by their different colors, and each network has their own router, along with their hubs or switches and their computers. So right now, as you can see, each network is just exchanging information within their own network. Their data is not going out on the internet, so they are not communicating with other networks. They are just exchanging data within their own network using their hub or switch. Now let's go ahead and exchange data between different networks. So let's say, for example, that this computer here on the red network wants to communicate with a computer here on the blue network. So for this to happen, the data packet has to leave their own network and go out on the internet. So the computer sends their data, and it goes to the network's router. And once the data packet reaches the router will look at the IP address of the data packet and then forward the data out on the internet to the next router, and then make its way to the blue network's router, and then to the intended destination computer. So in a nutshell, this is how routers work. So in conclusion, hubs and switches are used to create networks, while routers are used to connect networks.
Okay, no? So, mao na ilang difference, no? Sa kadagang taas-taas na istorya, mao lang yun eh. Hub and switch are used to create networks, di ba? Then, ang nag-connect og networks is the router. So, mao na yan ang iyang purpose, no? Si hub and switch may pagkaparehas, no? Okay. Na ko yung last video about firewall.
What is a firewall? Now, a firewall is a system that is designed to prevent unauthorized access from entering a private network by filtering the information that comes in from the internet. A firewall blocks unwanted traffic and permits wanted traffic. So a firewall's purpose is to create a safety barrier between a private network and the public internet. Because out on the internet, there's always going to be hackers and malicious traffic that may try to penetrate into a private network to cause harm. And a firewall is the main component on the network to prevent this. And a firewall is especially important to a large organization that has a lot of computers and servers in them, because you don't want all those devices accessible to everyone on the internet where a hacker can come in and totally disrupt that organization. So that's why you need a firewall to protect them. So a firewall that's used in computer networks is very similar to how a firewall works in a building structure. In fact, that is where the word firewall came from. A firewall in a building structure provides a barrier so that in the event of an actual fire on either side of the building, the firewall is there to keep the fire contained and to keep it from spreading over to the other side. So the firewall is there to keep the fire from destroying the entire building. But if the firewall wasn't here, the fire would spread over to the other side and then the whole building would be destroyed. And a network firewall works in a similar way as a structure firewall. It stops harmful activity before it can spread into the other side of the firewall and cause harm to a private network. So in today's high-tech world, a firewall is essential to every home and especially in a business or an organization to keep their network safe. Now, a firewall works by filtering the incoming network data and determines by its rules if it's allowed to enter a network. And these rules are also known as an access control list. These rules are customizable and are determined by the network administrator. The administrator decides not only what can enter a network, but also what can leave a network. So these rules either allows or denies permission. So as an example here, we have some rules in a firewall's access control list, and it shows a list of IP addresses that have been allowed or denied by this firewall. And as you can see, traffic from some IP addresses are allowed to enter this network, but traffic from one IP address has been denied. So if traffic from this IP address tried to get into this network, the firewall will deny it because of the rules that are set in the firewall. But the other IP addresses are granted access because the rules allow them. Now, firewalls don't just make rules based on IP addresses, but they can also make rules based on domain names, protocols, programs, ports, and keywords. So let's say in this example, the firewall rules are controlling access by port numbers. And let's say that the rules have allowed incoming data that's using port number 80, 25, and 110, and the data using those ports have been given access to this network. So any incoming data that's using those ports can pass through the firewall. But also in this firewall, the rules have denied any data that's using port numbers 23 and 3389. So any incoming data that's using those port numbers, the firewall will deny access and it won't get past the firewall. So in a nutshell, this is how firewalls basically work. Now, firewalls do come in different types, and one type is called a host-based firewall. and this is a software firewall. This is the kind of firewall that is installed on a computer, and it protects that computer only and nothing else. So for example, later versions of Microsoft operating systems come pre-packaged with a host-based firewall, and you can see that example here. And there are also third-party host-based firewalls that can be purchased and installed on a computer. So for example, Zone Alarm, which is a popular third-party host-based firewall. And also a lot of antivirus programs will have a built-in host-based firewall. And another type of firewall is called a network-based firewall. A network-based firewall is a combination of hardware and software, and it operates at the network layer, and it is placed between a private network and the public internet. But unlike a host-based firewall, where it only protects that computer, a network-based firewall protects the entire network. And it does this through management rules that are applied to the entire network, so that any harmful activity can be stopped before it reaches the computers. Now, network-based firewalls can be a stand-alone product, which is mainly used by large organizations. And they can also be as a built-in component of a router, which is what a lot of smaller organizations rely on. Or they can also be deployed in a service provider's cloud infrastructure. Now, a lot of organizations will use both network-based and host-based firewalls. They will use a network-based firewall to protect the entire network as a whole. And they will also use host-based firewalls for their individual protection for their computers and servers. And by doing this, it'll ensure maximum protection. Because if harmful data just so happens to get past the network firewall, the host-based firewalls on each computer will be there to stop it. So thank you everyone for watching this video on firewalls.
Okay, thank you everyone for watching the video of firewalls. Okay, so maulan to ang ato ang topic. So, any question?
Yes, sir.
Wala, okay. So, next meet